All right. Good afternoon, everyone. Thank you for attending today's webinar on performance paths for commercial buildings. This webinar will be recorded and the recording will be posted on the CO Code Adoption Toolkit. If there are any issues with the audio, please write me in the chat. My name is Kira Winkle, and I am a project manager with NORESCO. This series is sponsored by the Colorado Energy Office with training materials created by Anna McCullough. And let's see, I've got a couple slides to share. If I can get my screen sharing. I am guessing you are not seeing my screen yet. Is that correct, Anna?
We are not seeing it.
Sorry, everyone. Give me just one more second. All right, how's that?
Good.
Oh, except you do not seem to be seeing the presentation. Hang on. Sorry, everyone. I'm filling in for my coworker, Erica, and I'm getting this down. That might look better.
Great.
Okay. So we have been working with the Colorado Energy Office to provide trainings just like this one. This is the first of this webinar series. So make sure to register for the other trainings that are offered in this series. There will be a link sent out in a follow-up email if you would like to register for another webinar. Also, we are offering tailored group trainings or technical assistance for jurisdictions that are updating I-codes. So please reach out if to Erica DeLello to set something up. Slides still seem like they're not. There we go. Here are the upcoming trainings. Most of you know about the Code Adoption Toolkit and all of the resources available, including the recording from previous trainings. And today I want to highlight the Code Helpline. This helpline is available to anyone in Colorado on any of the I-codes or REACH codes. So for example, if you are a jurisdiction and need assistance on a plan review or homeowner or engineer with a question about code applicability, you can submit a ticket and a subject matter expert will get back to you in a couple days. You can access this helpline through the Code Adoption Toolkit or through this link. And those are all of my slides. Throughout the webinar, we do want to encourage questions, so please use the Q&A function, and I will let our presenter, Anna, know at the end of the presentation. There is also the ability to raise your hand to ask a question at the end of the presentation, and I can unmute you. And lastly, there will be a survey window that pops up following the webinar, so please do take a minute to provide feedback and we can continue to improve on these webinars. So today's presenter is Anna McCullough. Anna is a professional engineer with over 12 years of experience in HVAC design and building energy performance. Before coming to Group 14, Anna designed commercial and multifamily HVAC systems for 6 years. She is an expert in building analysis and using OpenStudio Energy Plus. Anna's design and modeling experience spans a wide range of building types, including airports, offices, schools, multifamily buildings, recreation centers, and government buildings. And with that, I will hand it over to Anna. Thanks, Anna.
All right. Hi, everyone. If you don't know me, my name is Anna McCullough, and we'll get started. So today, to set kind of the scene for performance compliance paths, we're going to talk a little bit about the prescriptive pathway first, which just kind of describes the energy code and why the performance path is the way it is. We'll then go through the performance path in the IECC, and then we'll talk about the alternate performance path, which is through ASHRAE, Section 11, or Appendix G, depending on your jurisdiction. Again, if you have any questions as we're going through this information, please ask them in the question and answer. Put them in the chat. I have them both open, so I will be monitoring, and I'm happy to answer them as we go along. Love to get this broken up for you guys a little bit. So really, when we're talking about compliance with the IECC via ComCheck or the prescriptive method, you know, there's three things that you have to supply. It's the mandatory requirements, the prescribed criteria, and then an additional efficiency requirements, which are 10 credits in the 2021 IECC. We'll talk a little bit more about what those 10 credits mean coming up here, but these are the three main pieces to code compliance. If we think more about the trade-off approach, which is what we have in ComCheck, ComCheck allows for some trading off within the envelope or within the lighting so that there's a little bit more design flexibility. When we are reviewing for a trade-off approach, which is what we see most often, we're looking for a ComCheck on envelope, lighting, and then mechanical and plumbing is all in one ComCheck. And we expect to see that they all have that green passes bar. Within ComCheck, what the program is doing is it is calculating the total UA of the building, which is the sum of the U factor of all of the assemblies, you know, the glazing, the roof, the walls, the foundation, any floors above grade, and multiplying those by their assembly areas. If each of those is less than or equal to 0, it will pass the ComCheck. So you'll see in some buildings that the prescriptive level of insulation provided in one small area of the walls might not meet the prescriptive insulation that's listed in the code. And the way that the design team is getting away with that is by using the trade-off approach calculation that ComCheck does for them. Within lighting as well, you know, we're looking for the total lighting power used in the building to be less than the lighting power used in the baseline or prescribed by the code. So ComCheck also allows for some trade-off between lighting power densities in spaces. Along with, you know, those mandatory requirements, the ComCheck, we're also looking for the additional efficiency package. We're used to seeing in the 2018 IECC, we had these 6 options. The design team picked one. It was almost always reduced lighting power density. And they selected that in ComCheck. You know, you wanted to make sure that ComCheck reflected the same efficiency package across all 3 ComChecks. So your architect, your lighting designer, and your HVAC plumbing designer were all selecting the same efficiency package in their ComCheck. And we just moved on, right? Things got a little bit more difficult in the 2021 IECC. So in the 2021 IECC, we now have to show 10 credits under Section C406. And what that means is there is this essentially a menu of options that design teams can mix and match based on their occupancy type in the building to come up with 10 credits. Within section C406, there are a lot of these tables. They are very large. They are broken up based on occupancy type. So you'll see we have the example group R and I occupancies table right here. And I did also want to point out that if we have a tenant space, they only have to receive a minimum of 5 credits from these tables. And there are some exceptions based on the base compliance of the total building when it complied with code. You know, if they have the reduced air infiltration, C406.9, for example, your tenant that you're reviewing is not going to need to show 5 credits. They just already are compliant with the additional efficiency requirements. We have created this chart here. So for climate zone 5B, we have each group and the available credits for each option. You'll see that different credits are weighted differently based on the expected energy use for each option. So you'll see, for example, in group R, which is our multifamily buildings, we're going to see that efficient fossil fuel water heaters are weighted really high, whereas for group B, you wouldn't get any credits for an efficient fossil fuel water heater. You guys will get a copy of these slides, so if you want to use this table for reference, you'll have that available to you. There have been, like I said, some changes from the 2018 to the 2021 IECC. We have seen, I've highlighted right here in purple each section that has had updates from the 2018 IECC to the 2021. And then we have 3 additional efficiency options that are new for the 2021 IECC. We'll go quickly through these just to kind of give you guys an idea of the efficiency packages that we're expecting to review for. But it gives you an idea of where the efficiency is going to come from in the performance model pathway. So the first energy efficiency package we have is the reduced lighting power. Low points available on this one because it's easy to meet. And we want to encourage design teams to do more than reduce their lighting power. We have quite a few points available for on-site renewable energy. The code sets a standard for the amount of on-site renewable energy required to receive these points. And then there are increased credits based on the amount of PV required. There's a calculation that will give them the number of credits. Service water heating. In section C406.7, the first credit option is recovered or renewable water heating. This is really hard to achieve, right? We would be expecting, well, what's required is providing a system not less than a renewable water heating system that is not less than 30% of the building's domestic hot water use, or 70% of the building's annual hot water requirement, if the building is required to comply with another section. But so this is really hard to achieve. This is going to be heat recovery from your wastewater, or it's going to be providing solar water heating on the roof. Really, to achieve this credit, very high first cost, weighted very heavily. If we provide a condensing water heater, points are available. This is the climate zone 5B points available. Heat pump water heaters are weighted slightly less. Energy monitoring, if the building is not required to have energy monitoring and energy monitoring is provided, 1 point is available. There are requirements around what that energy monitoring system has to provide. So if you did have a building that was complying with this credit, these requirements are all listed within section C406, and they match the requirements in section C405.12, which is where energy monitoring is required. Fault detection and diagnostics is a new credit available. So if you are providing a fault detection and diagnostic system on your HVAC system and it is supplied above what is required, it is supplied when it is already not required by code. There's a double negative in there, sorry. Then you could receive 1 point for that. There are requirements around what that fault detection and diagnostic system has to do to receive this credit. Okay. I know I kind of blew through the prescriptive and CommCheck approach, but I really wanted to talk a little bit about what energy efficiency measures are required in the proposed, so that we can talk a little bit more about why the performance method is the way that it is. Any questions on the prescriptive or CommCheck method so far? Great. Again, feel free to interrupt me if you have a question, or if you want me to go back and talk a little bit more about something, I'm happy to do that. So when we're talking about the performance method, there was a change between 2018 and 2021. The change was that in the 2018 IECC, you were only required to have 15% annual energy cost savings. And in the 2021 IECC, we have to have 20% annual energy cost savings. We'll talk a little bit more about what that means, what we're comparing against, but just to give you an idea, we are requiring an additional level of energy efficiency with the 2021 IECC. These buildings are still required to comply with all of the mandatory requirements in the code. Things like fault detection and diagnostics on outdoor air economizers, lighting controls, things like air barriers. I could go on. There is a whole list, a whole chart in section C407 of the 2021 IECC that really gives you a full picture of each mandatory requirement and where it is in the code. It's a very useful chart. Unlike the CommCheck or prescriptive method, performance compliance projects do not have to show compliance with section C406. So rather than showing some of these additional energy efficiency packages, what we have to show in the performance method is annual energy cost savings as compared to the baseline. So what all is required in section C407? Again, only those mandatory requirements are required. Prescriptive requirements do not need to be met. There is required to be a whole building annual hourly energy model. We're not just looking at loads. We're not looking at an output from an HVAC engineer's load sizing program. We are looking for a whole building annual energy, hourly energy model, which means the program that the energy modeler is going to use uses an hourly weather file that models the energy use of the building for every hour of the year based on its location. The proposed design is going to be compared to the standard reference design. We'll talk a little bit more about what the standard reference design is, but that's what we're going to call the baseline. Again, in the 2021 IECC, we have to show 20% less annual energy costs than the standard reference design. And our permit submittal must include a detailed energy modeling report. We'll go through an example of what one looks like, at least from my company. So when do we see buildings using this method? Number one, if they are very large. Typically, they're using the performance method, we're seeing more and more clients come to us looking for an energy model solely because ComCheck and Section C406 have become much harder to show compliance with. If their glazing area is greater than 40% of their window to wall ratio, if their window to wall ratio is greater than 40%, they have to comply via Section C407. Prescriptively in the code, you cannot have a window to wall ratio greater than 40% if you are using daylighting controls. And if you are not providing daylighting controls, you cannot have a window to wall ratio greater than 30%. So that's really important when we're reviewing to make sure that their window to wall ratio has been reflected accurately in their ComCheck. You know, if you look at the drawings and it's a building that looks like this, we would be a little bit suspect if they said their window to wall ratio is 40%. Other times we see design teams want to use Section C407. They're looking to trade off between their envelope efficiency and lighting and HVAC efficiency. So a good example would be a building that doesn't want to provide, well, I'll say this, but a metal framed building that doesn't want to provide continuous insulation, right? We can probably model them out of providing continuous insulation. We would never recommend that. But it is a way to get out of, you know, providing some of the things that are prescribed in the code. We got a question. What if it is a core and shell and we're not providing any equipment for heating or cooling? So if it is just a core and shell, typically we see those projects comply prescriptively. If there's no central HVAC equipment, we have to model the HVAC identically between the baseline and proposed in that case. So there's not a lot of trade-off available. Let me know if that didn't answer your question. The building performance method also allows design teams more flexibility, right? We can have a lobby that's really overlit with like very cool, I don't know, like track lighting and stuff. I'm not a lighting designer. But we can have some increased lighting power density in some spaces and offset that with a really energy efficient VRF system, for example. Or you know, there's just a little bit more flexibility around where they are investing their new construction budget, or honestly a renovation to show compliance with the code. We can help them decide where their money is best spent. And this is a common theme across all of my slides. The mandatory measures must still be met. If it's mandatory in the code, you still have to show compliance with it. And when we're reviewing for that, we want to see a full list of those mandatory measures and where they are located in the drawings. You guys don't need to come up with a list of the mandatory measures. So any questions so far on when we would use Section C407 or what we're reviewing for when we first look for that compliance? Great. Okay, so additional compliance requirements. Utility rates have to be identical between the standard reference design or the baseline and proposed. They can be from the Department of Energy, the EIA, or local utility rates. The code does not dictate which utility rates you have to use. You just have to use the same ones. Oftentimes, when we're looking at outputs from the energy model, we don't see that utility rates per kilowatt hour are completely identical. And the reason for that is you're looking at a blended rate. So you're looking at the cost per kW combined with the peak energy use cost combined with the kilowatt hour energy use cost. And that creates what's called a blended rate. So there'll be a couple cents difference between the baseline and proposed, but we want to make sure we're using the same utility rate structure. If the building has enrolled in an offsite renewable energy program, it is treated and priced the same as purchase energy, but it's removed from both the baseline and proposed. If they have on-site renewable energy, the savings attributed to that on-site renewable energy can be no more than 5% of the standard reference design annual energy cost. So this is really important. You cannot have what we would call just like a really thumb of a building, bad building, and just cover it with PV to get through the energy code, right? We want to make sure that the building is designed to be energy efficient with potentially some PV or renewable systems provided. But what we don't want to see is someone designing a really terrible building, like a metal framed building with no continuous insulation, and then just putting PV on top to make the building energy efficient. And then another big one that we always want to review for is that the unmet load hours for the standard reference design or the baseline must not be less than those of the proposed design, right? And the reason for this is that we will see annual energy cost savings if you have large amounts of unmet hours, right? Unmet hours are times when the heating and cooling set points in the building are not being met. So you're not cooling and heating enough. So if you have a permit submittal that comes in, the unmet hours are listed and your proposed has 1,500 unmet hours and your baseline only has 2. That's something I would make a comment on, right? It's not, we could be getting some annual energy cost savings by heating and cooling the proposed building less in the energy model. Any questions on any of that? Great. My mouse is frozen. Okay, so here's an example of a building performance letter that we submitted for. This is probably a 2021 example. And I have the different sections highlighted in here. So we have the mandatory provisions are shown in the red box. This is on a drawing sheet. Some jurisdictions like to see the compliance on a drawing sheet. Some like to see it as an 8.5 by 11 appendix. We do both very frequently. If it's on the sheet, it's a lot easier to find and gets missed much less often. So we have the mandatory measures located here. Very clearly, we have each mandatory measure listed and then where it is located in the drawings. We also want to review for the baseline and proposed inputs to the energy model. So we want to make sure that the standard reference design or the baseline was modeled correctly per section C407. We'll get into that a little bit in a minute. And that the proposed was modeled per the drawings, right? The correct HVAC system is in there. The efficiencies are modeled correctly, lighting power densities, all of that. You know, if you're looking at a school, for example, and the lighting power density allowed in the baseline of the classroom is 0.60 watts per square foot. But then in your proposed design, they're only modeling 0.02 watts per square foot. That should set off alarm bells, right? That's like one light in the middle of the classroom. So we want to make sure that the inputs are within the realm of possibility and they are accurate to what was designed. I do have this highlighted box here, a commissioning letter, if it's required by the code. And then we also want to see model outputs. So this is important. We want to make sure that the annual energy cost shown in the model outputs matches what is shown in the compliance letter stating what the percent of annual energy cost savings is. We're checking for unmet hours here. We're checking, getting a gut check for energy use, right? If we have a building that is all electric, for example, and we look at these model outputs and it's showing that the heating source is natural gas, we know that something hasn't been modeled correctly. So we have these items available within the performance letter to make sure that the drawings were modeled correctly, that the energy model is accurate to what the drawings show, and that the results make sense. You don't have to be an energy model to decipher some of these general themes within the results. Things like, what is the heating energy source? Is it natural gas? Is it electricity? If they have rooftop units with natural gas heat and electric reheat, we would expect to see some heating use in both natural gas and electricity. Some general themes of how the building is going to operate. Okay. So now we're going to talk about the standard reference design. I do have, if the 2021 and the 2018 IECC are different, I will show both. There were minor changes from the 2018 to the 2021 IECC around the standard reference design, but they'll be shown here. Here is that table C407.2 that talks about, that lists all the mandatory requirements in the code for the 2021 IECC. So that's available for your use if you need it. So you'll notice in the 2018 IECC, the above grade walls were to be modeled as mass, where the proposed wall was mass, otherwise steel framed wall. And now in the 2021 IECC, the type of wall is modeled the same as the proposed, which means that if you have a wood framed wall in the 2021 IECC, we would have wood framed in the standard reference design. The U factors listed in the performance documentation for the standard reference design should match what is in the prescriptive U factor table, C402.1.4. And the proposed U factors listed should match what is in the design. The standard reference design, a little bit more about the envelope. All of the insulation and glazing meet the prescribed insulation levels and glazing U factors, as well as solar heat gain coefficient. If you have greater than 40% window to wall ratio in your design, you can only have 40% as a maximum window to wall ratio in the standard reference design. We want to make sure that they are taking a hit for providing so much glass above what is allowed to be included in the design prescriptively. Skylights are only allowed to be 3% of the gross roof assembly in the standard reference design. And if there is shading, there is no shading modeled in the baseline. Here's a good example of a window to wall ratio in the standard reference design versus the proposed. So you'll see in the standard reference design that we have much less glazing shown to meet that maximum 40% window to wall ratio. And in the proposed, we're at probably closer to a 60 to 70. So sorry, my toddler is home and he broke into my office. Much closer to a 60 to 70% window to wall ratio. In the standard reference design, we also would always expect to see code prescribed lighting levels. So all of the lighting power allowances are modeled per section C405.4.2, as well as daylighting. So oftentimes daylighting will be required in the standard reference design, but the lighting power densities in the proposed model will be so low that daylighting doesn't need to be provided. So we want to make sure that lighting controls are called out accurately to make sure that the daylighting and prescriptive requirements and lighting controls are modeled accurately in the standard reference design versus what may or may not be provided in the proposed based on their design. And a good note on this slide as well is that interior gains are the same between the standard reference design and the proposed. So if you're in an office, for example, you're modeling the same amount of office equipment in the baseline as the proposed. Okay. So in the mechanical system, there are these two charts, C407.5.12, which is the HVAC systems map, and then C407 I think it's 0.5.13, which is the specifications for these different system types. So your proposed system type tells you what your baseline system type will be, or your standard reference design system type. We start off with your condenser cooling source. If you are cooled, if you have a rooftop unit that's DX, a direct expansion rooftop unit, it's cooled by air. You're down. Let me find my mouse, so sorry. You're down here, where your condenser cooling source is air. Then if we're still using our same example, a standard kind of rooftop unit with gas heat, and let's just say it's electric reheat, your heating system classification is going to be fossil fuel, right? We're an office. It is a VAV rooftop unit, so we're system 4. If we go to this chart, you'll see it's a packaged variable air volume with reheat, VAV, direct expansion cooling, and a hot water fossil fuel boiler is providing your heating. When we were originally talking about this system, I said that it had electric reheat. There is a line in the code where your secondary heating system must be modeled identically between the baseline and the proposed. So, because in our proposed design, we have a VAV rooftop unit with gas heat and electric reheat, we now change our baseline system to be VAV, direct expansion with heating hot water in the rooftop unit in our standard reference design, but it's going to have electric reheat so that we have the secondary heating system modeled identically between the baseline and proposed. It's really important, and this mapping system can get really confusing based on the type of system that you have, but it's important that it makes sense, right? We don't want to see, for example, a water source heat pump building office. We would expect to see water source heat pumps just per this map in the standard reference design as well. We would have a red flag if they said they modeled PTACs in the baseline, right? Or just single zone rooftop units in the baseline. That's not, we want to make sure that the standard reference design HVAC system matches what the code tells us it has to be. I'm going to do one more example. And we can do that water source heat pump example just to make it really clear. So if we have a water source heat pump system, we know that our condenser in our water source heat pump is cooled via water. So we're in this upper half of the chart. And then we have a heat pump. It's a water source heat pump. So we know we're in this secondary system. Or second line in the chart, I'm sorry. Row, that's what that's called, second row. And so then we know we're a system 6. So if we go back to this chart, you'll see that your system type is water source heat pump, constant volume, direct expansion, an electric heat pump, and then the boiler is providing the heating to the loop. This can seem very overwhelming to try and work your way through this HVAC systems map. But I do think, for your typical system, what we really do want to see and what's going to raise a red flag for you is that if the baseline system type or baseline heating system doesn't have the same fuel type as your proposed heating system, that there's an issue there. And so that's going to be a good red flag for you to check. The mechanical controls in the standard reference design must meet the mandatory and prescriptive requirements. So a good example is that outdoor air economizers are prescriptive. If, for example, our proposed system is VRF with a DOAS, there's not going to be an outdoor air economizer unless our client has like a ton of money and a lot of space for ductwork. But in this example, we could go through that HVAC systems map and find that our standard reference design system would be a VAV with parallel fan powered boxes. And in that case, it would be required to have an economizer. So in the standard reference design, we want to make sure that those prescriptive requirements are being modeled, and your energy modeler isn't taking credit or showing annual energy cost savings for something that they shouldn't be, right? Outdoor airflow, as kind of a side note, outdoor airflow has to be modeled identically between the baseline and proposed. So we want the same amount of outdoor air in the baseline as the proposed. Okay, that was a lot of information. Do you guys have any questions before we very quickly go over ASHRAE 90.1 2019 as our kind of secondary compliance? What would be the best path for large additions that require existing building retrofits? It really depends. Typically, what we see is that we would have I am an energy modeler, so I see more energy models than anything else. And very frequently with existing buildings, we will see an energy model. If you are increasing you're taking, for example, an unconditioned space to a conditioned space, that's when the prescriptive option might be easier to comply with. But if you are modeling a large addition with a small amount of retrofit, I would recommend the performance pathway. Another question, hunting cabins and similar to buildings that are non-conditioned or low energy, what would modeling a building with limited winter or seasonal heating only building look like? Heating temperatures are kept at a minimum, and building operation for only a season instead of a full calendar year. So, in this case, we would expect to see no cooling, obviously. You want to make sure that the temperatures that are stated, in the energy model inputs, we're looking for what temperatures are you modeling the building to? Are you modeling it to 80 degrees cooling? Or are you modeling it to 68 degrees cooling? Or in your case, heating. We want to make sure that the occupancy schedules are correctly listed. So a lot of times you'll see, at least in the compliance documentation that I provide, we'll say, if it's a school, we'll say school district operating hours, or we'll say typical office operating hours. A multifamily building would be 24/7 occupied. You want to see that for this specific building, they have accurately modeled the operating hours. And then also we would expect to see kind of low energy, reduced heating. This is a building type that I would expect it to comply prescriptively. There are exceptions in the code for low energy use buildings based on the heating BTUs per square foot. So that would be something that I'd encourage you to look at before providing an energy model. Thanks for asking questions, guys. Always makes it more interesting and keeps me on my toes. Never know what I'm going to get. Okay. So very quickly, we're going to talk through ASHRAE 90.1, and then we'll leave a few more minutes for questions at the end. So if your design team so chooses, they can comply with the 2021 IECC via ASHRAE 90.1 2019. It's listed as a compliance pathway, and there are some really important key differences that I want to cover very quickly. The first is that there are no additional efficiency requirements. They just have the mandatory requirements and the prescribed criteria. Sorry. You can still use CommCheck for this. You can do that same UA trade-off, the lighting trade-offs, but again, they should have ASHRAE 90.1 2019 selected as their code. And there are, again, no additional energy efficiency requirements, no packages from Section C406 that we're used to seeing. The reason for that is that ASHRAE typically has more mandatory measures than the IECC does, and they are typically have slightly higher energy efficiency than we see in the IECC. So they don't include the additional efficiency packages that IECC does to try and kind of level the playing field between the two codes. Compliance paths, I guess I should say. Another big difference between ASHRAE 90.1 2019 and the IECC is that ASHRAE 90.1 has two compliance pathways. The first is Section 11, and the second is Appendix G. Appendix G has to be selected or listed as a compliance pathway for your jurisdiction. If it is not listed, all performance compliance for ASHRAE 90.1 2019 must be through Section 11. Section 11 only requires you to show $1 in energy savings as compared to the standard reference design. Here's a list of mandatory measures in ASHRAE 90.1 2019 that are slightly different than the IECC. And we're not going to go through them just for the sake of time. And then we're going to talk really quickly about Section 11 and Appendix G and the differences between those and how red flags we should look for in our reviews. So Section 11 is very similar to Section C407. The 5% contribution from on-site renewables, the HVAC system types, the prescriptive levels of insulation, all of that is identical between Section 11 and Section C407, those requirements. They obviously have to be referencing ASHRAE 90.1, not IECC for the insulation and glazing, but the kind of methodology of modeling are identical. We start running into a lot of differences when we start talking about Appendix G. So Appendix G, you have to show that the performance cost index, which is a whole calculation in and of itself, is less than the performance cost index target. That is also a calculation in and of itself. So if your design team said, here's our compliance documentation, we're complying with Appendix G, you're not looking for annual energy cost. You're looking for what is your PCIT and what is your PCI. Other than that, the idea is the same. Another big difference in Appendix G is that they now have what is called a stable baseline. So we are actually comparing a new construction, our design, against a 2004 building. So if we take our design and make it comply with ASHRAE 90.1 2004, in terms of lighting power densities, prescriptive compliance, prescriptive insulation levels, prescriptive glazing, we're comparing our design against that. Appendix G has what are called building performance factors that are included in the calculation of your target. So your baseline no longer will change from code cycle to code cycle, but how you calculate your target will, and it will become more and more difficult to meet that target, requiring more and more energy savings. The other big difference in Appendix G, and why I want to bring this up, is that we are modeling in Climate Zone 5B, all of the baseline heating, domestic hot water heating, will be natural gas, no matter what. It makes it very difficult to meet this pathway if you have any sort of electric heating in the building. So we want to make sure if they are complying with Appendix G in ASHRAE 90.1 and you're looking at the outputs from their energy model, all of their heating should be natural gas. All of their domestic water heating should be natural gas, whether or not they have electric heating in the building. There is the same note about 5% contribution from on-site renewables, but yeah. Okay, and that was what I had for you. Here is the Colorado Codes helpline slide again. The link is there as well, available to anyone in Colorado, and a subject matter expert will reply within a couple of business days. Does anyone have any questions? If you do have questions and you don't, or you think of them after this, feel free to shoot me an email or leave me a voicemail, call me, and I will get back to you as soon as I can.
Great. Thank you, everyone. And once again, I hope that you will take the opportunity to complete the survey that will pop up after we end the meeting. Have a great day, everyone. See you later.